Okay, so now in this lecture, lecture number 2, quantum mechanics, we will see the journey from classical to quantum mechanics. We will see it in brief way because we will not go in detail. Now, when we think about classical mechanics, so we always, got the idea of Isaac Newton, Galileo Galilei, and there are many more scientists at that time who explained the real physics to us, right? Now, let's see what Newton said about, the classical mechanics. Basically, we know the things or the objects at macroscopic level, their motion was governed by the Newton's law, which he gave the formulation in mathematical description. Again, it began in the late 17th century when it was the era of Isaac Newton, Galileo Galilei, and there are many more, right? There were many more. So again, it began in the late 17th century with the formulation of classical mechanics. Now, what is meant by formulation of classical mechanics? So, formulation simply means F equals ma, right? Kinetic energy we know, half times mv square. Gravitation law, how can we forget it? Gravitation law, it is the basic and most famous formula of that era, right? Gravitation law. So these were the formulation which were given by Newton. Now, which provided deterministic description. Now, deterministic description means they provided, Newton provided actually this formulation, and this formulation governed the motion of macroscopic object in deterministic way. Deterministic means we can easily determine the position, location, or speed of any particle, right? But in quantum mechanics, it becomes unclear. It becomes uncertainty. So again, deterministic description means these formulae govern the exact behavior of macroscopic object. There is no probability like it may happen or that may happen. There is deterministic. If it is this, then this has to be done, right? Suppose when we send satellite from Earth to the Mars or any planet, so we know exactly that where the mass will come after 4 months. So it is determined, okay, by Newton's formula. So this actually basic the from classical mechanics. But what happens to the classical mechanics where we introduced quantum mechanics? In fact, there are some key limitations which quantum mechanics could not explain. So let's we just see those, then we will study further, right? Okay, so now let's we see the key limitations faced by classical mechanics that were addressed by quantum mechanics. Okay, so the first is wave particle duality. We have already discussed in the beginning, like electron or particle may behave as a wave, and radiation, which is wave or light, may behave as a particle, right? So the wave particle duality could not be explained by classical mechanics, because classical mechanics says if you see a particle, then this is a particle, not a wave. Wave is a wave, particle is a particle. Particle cannot be a wave, and wave cannot be a particle. This is what classical mechanics says. But when we see at the quantum level, at the atomic level, the things behave differently. How? See, particle may behave as a wave and wave may behave as a particle. So this is wave particle duality. Next, we have uncertainty principle. Recently, we saw that the Newton has given some formulation which explained the classical behavior of macroscopic object in deterministic way. But when we say uncertainty principle, it simply says that when you have quantum states, what is meant by quantum states? It could be position, momentum, speed, or whatever, characteristic of the particle, right? Quantum state. We will see in detail this kind of thing. But now let's see once again. So things in pair becomes uncertain. Okay, let me just write. So what is uncertainty principle? It says quantum states or things. Let me just write things. It is much better, So things become uncertain in pair. How? Uncertainty principle says when you have some kind of position of any particle and you have momentum of a particle, right? So this is the formulation which we'll see later in detail, but here the main thing is this: position and momentum of a particle is given in pair. So when you see two quantum states or two information of a particle in pair, it becomes uncertain. When it becomes uncertain, when it is in pair, right? So when you go to find position of any particle, then you can't tell that what is its momentum. For example, suppose here we have the orbit of an electron and how electron is behaving, revolving. Suppose it is behaving in simple orbit. So when I just want to know the location of particle or electron, I just send some light signal to know its location. So when it receives this light signal, its speed increases and momentum becomes unclear. So when we go to find its position, the momentum becomes unclear. Therefore, things becomes uncertain in pair. In simple way, when we talk about the location of, or when we want to send satellite or rocket to the Mars, so what we know? Suppose this is the orbit. Here we have Earth and here we have Mars. So when we try to send satellite or rocket to the Mars, so after 4 months it will be here, right? And we know it in deterministic way. So we can easily send the satellite, but at quantum level, we can't tell that after 4 months or after some moments, after a few moments, where the particle will be. Therefore, the things becomes uncertain in pair. It is the basic of quantum mechanics where the probability takes place and that probability will be solved and will be faced by some wave function type things, and we will see in detail. But now let's see what is quantization of energy. In fact, when we talk about black body radiation, which we have studied in our junior classes, but even I will teach you that what is black body radiation in next lecture. But even Max Planck explained that when you go and heat some material, it emits certain radiation, and it is always, it is obvious. When you heat some material, it emits some radiation. So according to classical physics, when you heat any material, its intensity increases continuously. But in reality, it does not happen. Every individual color has its own maximum intensity. We will see in black body radiation where Max Planck stated that you can easily quantize energy of any particle by using E equals h nu formula, right? So we will see it in detail, but this thing according to classical mechanics was wrong, because classical mechanics was saying that when you heat a material, its intensity increases continuously, but it does not happen in the reality. So we will see in detail how quantum mechanics helps to explain. Next is wave function collapse. So what will be wave function? I will teach you, but let's just see one example. Suppose you just go to your friend or you want to surprise your friend because it is his birthday at any time, right? Suppose today. So today your friend has birthday and you want to surprise him, right? But you do not know where he is exactly. So you know that he may be found at his favorite places, and his favorite places may be at this point, at this point, at this point, and at this point. So these may be his favorite places and you are here. So you may say that he can be found at this place, he can also be found at this place, he can be found at this place, and he can be found at this place. So your friend can be at multiple states or at multiple states at one time. But when you do calculations, by putting certain information about your friend, about your friend's favorite location. So you get some probability, and that probability tells you that your friend can be found at this place, and that probability may be 98%, 80% based on your calculation, based on your information. How you will put your information, I will teach you, because it helps, because to know the probability we take the help of Schrodinger wave equation. But let's we just see here, when you find your friend at many at many places, so you find its probability that where he can be found at one place. Okay, so you just put information and you get the probability. So here you find your friend at the maximum probability, and so at this time this probability, this probability, this probability, and this probability collapses and gives you one maximum probability finding at one location. Means these are the probability where your friend may be found, right? So when you find probability, so this probability diminishes, or it get extinct. It also, and this probability collapses at one location, and you find your friend at this place. So this is wave function collapse, where the probability of finding many places, of probability of finding a friend at many places collapses into one single high probability. So this is wave function collapse, right? So next is entanglement. Last in the last video I taught you that what is entanglement, because this is the phenomena where the particle are entangled by some kind of information which could not be explained by classical physics or special relativity. So it is different tasks which we have seen earlier, right? So by the next time we will meet and we will see that all these things in detail, because I want to teach this quantum mechanics for beginners, not for advanced, right? So let's meet in the next class.